Hello everyone, welcome back again. Today we are going to have a look at question number 9 of the 2018 November question paper for grade 12. In this question, we are asked to prove the theorem that states that J plus L, so that's question number 9.1, J plus L is equal to 180 degrees. We're asked to prove that the opposite angles of a cyclic quad are equal to 180 degrees or are complementary. How do we know that it's a cyclic quad? So as the statement says, that the JKLM is a cyclic quadrilateral, and O is the center of that cyclic quad. So now let's begin with the theorem. It's a very simple theorem. Just master the drawing of the important features to prove this theorem. So the first feature to draw here is what is going to lead us to a theorem that will make everything simple. In the last video where I was proving the turn chord theorem, going to attach it, I was talking about the importance of drawing on the diagram that you are given, so that the marker can see your work, follow your steps, and then sort of understand where you made a mistake if you did. So the first thing we draw here is a line from K to O. Then we draw another line from O to M. This is the center. And then we are going to divide O into O1 and O2. So this angle here is O1 and this right here is O2. Alright. Okay, so what we know is that now there is this arc here, arc KM. You start here and go here. This arc subtends this angle O1, and the same arc subtends the angle J. So it is safe to say that O1 is equal to 2 times J. What is that theorem? The angle at the center is twice the angle at the circumference. But what is important with that theorem is that those angles need to be subtended by the same arc or chord. So if we're to talk of a chord, we'll also draw a chord here. That chord is still Km, but now let's just use the arc. So the reason is that angle at center is 2 times the angle at circumference. Alright. And then the same applies for O2. So O2 is subtended by the arc Km also, but in this direction. So if you start here, go all around, you see that there is an arc here, Km, which subtends. So when something subtends, doesn't necessarily mean that it must form some sort of it mustn't mean that it must only cave in or form a lesser angle. So in here we see that this angle is a reflex angle. It's not a straight line, it goes past 180. So that angle that is subtended by this arc Km is also, we can also see that that same arc Km subtends the angle J. So if you follow the drawing, you'll see that that arc subtends this angle. So O2 is equal to 2 times L, which is the same reason. So this is just saying it's the same reason as that. Angle at the center is twice angle at the circumference. But what we also know is that if we have a straight line, the angle of a straight line. So one angle this side, that angle in there is equal to 180. And then the angle on this side is also equal to 180. The summation of these angles of a straight line, so the revolution in there, should always be equal to 360. So angle at the center, the revolution. So if you had to add all angles that make up that point at the center, they should equal to 360 degrees. So we know that now O1 plus O2, O1 plus O2 should give us 180 degrees. No, sorry. O1 plus O2 should give us 360 degrees. That is revolution angles. So if O1 plus O2 is equal to 360, it means that, so here what we simply did is to add the left hand side and the right, and the left hand side of this equation and the left hand side of this one, which means the same must hold, that this right hand side here plus this right hand side here should also equal to 360, because they are all equal to those two angles. So we can say 2 times J plus 2 times L should be equal to 360 degrees. We can take out, or we can divide by 2, divide by 2, divide by 2. And then we have that J plus L is equal to 180 degrees. And the reason that we all know is that opposite angles of a cyclic quad are equal to 180, or are complementary. I was trying to draw a cyclic quad in there, but that's basically how to prove that theorem. Thank you.